whenever we are going from a rarer medium to a denser medium, which means the medium is changing, the speed of light changes. Okay, the speed of light changes. Here, it's a low traffic zone. Okay, so whenever there is low traffic, our cars can move higher at a higher speed. This is a high traffic zone. Shamik, switch on the camera. High traffic zone. तो यहाँ क्या होगा? Speed low हो जाएगी. Whenever there is speed change, so if you see that the thing is moving slowly, and there is a small deflection that you see here. Shamik, कुछ खाया बेटा? Did you eat something?
I ate in school.
Are you hungry? If you want to eat your food along with the class, do it.
No, it's okay.
You're okay? Fine? Pani wani piya? Okay, ठीक है. चलो. So now you're going from a denser to a rarer medium now. So again, the speed will go high because of आपको low traffic zone में चले जाओगे. Because of that, there is continuous change in speed, right? And there is a change in angle also at which it is moving. All right. So, and you remember, I told you what was the word last class? What was the word? What was the word? For refraction. How do you remember? Denser to rarer, rarer to denser. क्या होता है? बोलो. Drawn. Okay. What is it?
Denser to rarer, away from normal.
Very nice. Very good. So that's what will happen. And since you're going from denser to rarer, you'll go away
denser
from...
to rarer is away from normal, rarer to denser is close to normal.
Yes. So when the light ray passes from one medium to another, N, which is, I'm going to tell you what is that. So one was the concept of speed of light. Second is the concept of moving towards and away from the normal. And third is a concept of refractive index. Okay. So every object, ये जैसे ये हो सकता है glass है, ये हो सकता है water है, ये हो सकता है diamond है, कोई भी object होगा, they will have a refractive index. Okay. And that refractive index has a relationship with the angles that are being formed. Okay. And what is that relationship? Refractive index is equal to sine of I upon sine of R. अब trigonometry तो पढ़ा है. Shamik, फोन छोड़ दो बेटा और बिल्कुल आ जाओ close to the screen and concentrate here.
My phone is there.
Turn towards the screen.
Yeah, share it.
Right. So sine I upon sine R. That's the relationship. I क्या है? What is I? Angle of
incidence.
And what is R?
Refraction.
Angle of refraction. Refraction, not reflection, refraction. Okay, clear? So this is an experiment where you're trying to find the refractive index, and you're trying to find the refractive index of glass. Okay, so see what we are doing here is glass block. ध्यान से देखो, glass block है. ये क्या है? Ray of light. So for producing that ray of light, you have a ray box. So some ray of light is being produced, and what you will do there, obviously you know what is the normal. You make the normals, and you keep changing the value of I, this angle. Okay? Because of changing the value of I, R will change, right? So every time you do that, you note down. So you start with an initial angle of 30 degrees, and you keep changing. Repeat this with from 10, 20, 30, 40 till you go up till 80. 10 से लेके 80 तक जाओगे, ठीक है? And corresponding R calculate करोगे कि जो R बन रहा है उसको भी measure करोगे, ठीक है? And then you will find out N is sine I upon sine R. So suppose आपका I का value है, suppose sine I is suppose 30 degrees, sine R is some angle, so it will be towards the so let's say 10 degrees. So जो ratio आएगा वो हमेशा same होना चाहिए. That is what, no matter whatever angle you're changing, क्योंकि अगर I चेंज होगा तो साथ साथ R भी चेंज होता जाएगा, तो sign of each one of them will also change. So the ratio will remain the same, and that's how you calculate the refractive index. How understood the process to calculate refractive index? बहुत आसान है, nothing great about this. Now the question says, calculate the refractive index when light passes from air to glass. So this is your glass. ये air है, ये glass है, ये air है. Angle of incidence is 30 degrees. So let me make a normal first. You get normal. Angle of incidence is 30 degrees from, and the angle of refraction is 19 degrees because it is going from a rarer to a denser medium. Rarer to a denser medium is towards the normal. So this one is 30 and this is 19. Okay. So what will be the refractive index N? What is I, Trisha?
I is 0. It's 30.
30 degree. Shamik, R क्या है? Trisha, R क्या है?
R is 19 degrees.
R is 19 degrees. Okay. So what should I write the formula now?
Sine 30 upon sine 19.
Sine 30 upon sine 90. Okay. Sine 30 upon sine 19, and that is equal to n. Calculate and give me the value. Put it in your calculator and give me the value.
One 1.54.
What's the answer?
1.54. If you round it off.
Is this the value that you're getting?
Yeah.
Very nice. Great. Next one. Do this. Shall we calculate this? You got disconnected. What happened?
My laptop died. Once.
अभी चार्ज में लगाया?
हाँ.
Do this question. You'll have to write it, Shamik. No, don't do it. mentally.
What is the refractive index of air?
What is the
Air का refractive index.
We don't know. Why do we need that?
Oh, हाँ. Wait.
I got the answer.
क्या है आंसर, Shamik?
I'm checking. So it's sine 50 upon 1.5.
Sine 50 upon
1.5.
Answer दो, final answer. You have to put it in the calculator. अरे इतना इतना कैलकुलेशन नहीं है.
Auntie,
जल्दी
I have
बताओ.
Google sign calculator and everything. I don't have that right now.
Trisha, give me the answer.
It's around 0.51.
0.51.
How?
Okay. See. 0.51 is what you said, right? So n is 1.5. Sine I is sine of 50 degrees upon sine R. And we have to find out what is R, right? So पहले तो हम sine R निकाल लेंगे, which is sine 50
by 1.5
upon 1.5. This much you got? Sine 50 is 0.766 divided by 1.5. यहाँ तक तो आंसर आ गया होगा 0.511. इतना तो कैलकुलेटर से आ गया होगा, right?
Now sine inverse.
Now you have to find out what is R. For that you do in your calculator, there is a button which says sine inverse, which looks like this. Sine inverse, it's -1, 0.511. So that value you will get as 30.7 degrees as the answer.
Phone ka calc doesn't work for some reason.
Okay. Clear हुआ Trisha? Yeah. So this is one topic of physics where you will be needing a lot of trigonometry. Lot नहीं, मतलब you will need the trigo knowledge here. Clear हुआ? Everybody? चलो ये question. Calculate the angle of incidence when light passes from air to water if the angle of refraction is 20 degrees and the refractive index n is equal to 1.53. Amar, you will tell me the formula and everything. If your calculator is not working, Trisha, you will tell me all the values.
Oh, then I got the answer.
बताओ.
Sine 20 into 1.33 का sine
पहले
inverse.
बताओ, पहले formula बताओ.
Sine inverse upon sine R is equal to
Formula. You always have one mark for the formula. So you always start like that. Say what is the
that's what I'm
formula.
saying. Sine I upon sine R, I said inverse by mistake, is equal to n. So
n, okay, is equal to sine I upon sine R, which is equal to
1.33.
Sine of पहले substitution के marks होते हैं. What is your, when you plug in the values, you get marks. So sine.
What are we finding? Like, okay, so sine R is equal to.
Well, first you plug in the values, na? Plug in the values. Sine
I, na?
so
R
say
into
I. No, first you plug in the value. उसके बाद हम बाकी का काम करेंगे. Upon sine of what?
20.
Sine 20. Now this is so formula. Then plugging in. They have marks in your mark scheme, okay? And then you calculate. फिर calculation का marks नहीं है. फिर straight away answer के marks. Correct answer के marks. Got it? Got my point now? This will carry 1 mark. This will carry 1 mark. Calculation के कोई marks नहीं है. एंड स्ट्रेट अवे जो आंसर आएगा n की वैल्यू उसके मार्क्स होंगे. सो 2 मार्क का काइंड ऑफ क्वेश्चन. सो यू नीड टू सी अकॉर्डिंग टू द मार्क स्कीम. प्लगिंग इन का पूरा मार्क्स होता है. सो यू हैव टू शो द करेक्ट प्लगिंग इन ऑफ द दीस थिंग्स. n is given as how much? 1.33. हाँ, तो अब बताओ sin I is equal to
sin 20 into 1.33 का whole sin inverse.
sin 20 into 1.33. नहीं, का whole sin inverse अभी नहीं. इसकी पहले values
Like after
निकालोगे.
you solve that and then you do sin inverse.
Yeah, Trisha, now you tell me the values. Sin 20 is how much?
It's 0.34.
And 1.33 से multiply करके क्या आंसर आ रहा है?
It's 0.45.
0.4
5.
4
45.
45. Okay, and then you will do sin inverse of this, isn't it?
Yeah.
इसका फाइनल आंसर बताओ मुझे I की वैल्यू.
I'm getting 26.74
degrees.
degrees.
Okay. Okay, Trisha, so one small thing. सब कुछ ठीक है. Whenever you're taking just sin 20 लिया तो go up till 3 decimal places. ठीक है? And then finally bring it down to because 3 significant figures है तो उस हिसाब से decimals भी लेना. 3 significant है तो 4 तक जाना होगा आपको multiply करके. So that you can round it off later. वरना थोड़ा सा sign में mistakes आ सकते हैं. ठीक है?
Okay.
Right. Because this was coming out to be 455, जिसकी वजह से this is not 26, it's 27. If this slight mistake also, answer will be considered as wrong. ठीक है? Clear? So do not round off. Take full values beginning में. Rounding off has to be done at the end. अगर हम हर step पे rounding off करना start हो जाएंगे, तो हमारा final answer will be very very different from what the actual answer is. ठीक है ना? Those slight mistakes will create a big mistake in the entire paper, in the entire answer. Okay. Chalo. Shamik, Trisha, give me the answers one by one.
Done.
बताते जाओ.
Okay, I have 2 left. Done. I can't find like the final values, but I got the formula.
Trisha, tell me the final values. Shamik, आप मुझे R का वैल्यू बताओ क्या होना चाहिए और Trisha will give the final values. Okay. What Trisha?
So R is in first. So the first one is sine I upon sine 20.
Sin I upon sin
Sorry.
20.
Wait.
Sin inverse of what? R निकाला ना, sin inverse of what?
मैं wrong वाला देख रहा था.
Wrong हो गया?
मैं wrong वाला आंसर दे रहा था. एक सेकंड लेबल नहीं किया है. Sin 50 upon 1.5 का sin inverse.
हाँ, Trisha आंसर बता बेटा.
I got 35.17.
35.17 can be rounded up to 35.2. Next, Shamik.
Yeah. So the next one is let me find it. Got lost. It is sine 30 upon 0.67.
Trisha, give me the answer.
48.245.
245. So 48 point.
Maybe I did some error. I took 3 significant figures though
For what?
when I was doing the calculations.
Okay. Just a second. You must have done. I'm supposed to find out R now. So sine inverse. So sine 30 divided by 0.67 divided by 0.67. So what value did you take? 0.746286, right, Trisha? That is when you divide
746.
746, na? So that is what I'm saying, that you don't, there you will not take 3 significant figures. 3 significant figures is for the final answer. There you have to take the entire value. This full value you have to take.
But there are a lot of decimals.
That's okay. You're anyways doing it on a calculator. So sine inverse of that, then you get exactly 48 point. No, it's coming out to be 48.3 only. Did you get 48.3?
Yeah, approximately.
That's 48.3. But what I meant was, do not use 3 significant figures in between calculations. Otherwise, your answer will be wrong. Okay? You have to take the entire value or at least 4 to 5 decimal places. Because you're anyways doing it on a calculator, no?
Yeah.
Next one. जल्दी बता दो मुझे. शामिक बताओ, वैल्यू बताओ और त्रिशा आप आंसर बताओ.
So sine 50 into 1.13 inverse.
त्रिशा आंसर. त्रिशा आंसर.
Wait, could you say it again? I don't know how to put it in the calculator.
Sine 50 into 1.13.
Haven't you done it, Trisha? किया नहीं क्या?
I have, but it takes time to put it in my calculator.
No. So haven't you already done it? You are putting in the calculator now, or you've done it already?
I haven't done it yet. I only did it till the second question.
Acha, okay. Okay. I think can we do the rest of the questions on our own? These are simple questions only. You just have to find out the values. Trisha, fine now. I want to go to another topic. What is the phenomena that you see here, Shamik? क्या है ये?
Dispersion. We did this in class today.
Okay, क्या होता है इसमें?
Basically, when the light enters some kind of object, for example, a prism, it splits into different colors or like, waves.
Waves, okay, different
Every
colors.
different
Okay,
color has different kind of frequency or wavelength.
okay, and wavelength, right? So it's always which one first?
Red to violet.
And the
Red
to
has
violet.
the most wavelength and violet has the most frequency.
Frequency, okay, ठीक है. So so I think there is this phenomena that when white light is entering into a prism, okay, any refractive material medium, then in that case, the white light splits into the various frequency because they have different speeds. They have different frequencies, they have different wavelength, because of which they are coming out at a different, there is a deviation in them. There is a change in the speed for which they are coming out. So that's why what you see here is light. It's splitting into different lights. And what are the 7 lights that it is? These are the rainbow colors. So what is it? Vibgyor.
Violet, indigo, blue, green, yellow, orange, red.
And the violet is the lowest one here. Violet is always at the end, and red is always at the top.
Yeah.
Okay.
Slowest
And
and highest frequency, least
right.
wavelength.
Right. So we are going to get into the detail of all of that now. So this part is understood. This phenomena is called as dispersion of light. Okay. Chalo, quickly batao. Trisha, start reading the first statement and the first blank, followed by Shamik.
Refraction occurs when a wave changes speed
Continue.
As it crosses the boundary between 2 regions.
Okay. Next, Shamik.
Direction.
Read the statement.
Sorry. The direction of the wave also usually changes.
Next, Trisha.
Light rays deviate towards the normal when they pass from less dense air to more dense. I'm not sure.
Perspex, which is a material.
Okay.
In this case, they've taken the material. Okay, next one, Shamik.
The greater the angle of incidence, the greater is the dispersion. Deviation.
Trisha.
Different colors of light deviate by different amounts. Violet.
Shamik.
Violet deviates the most.
Continue, Shamik.
A prism can be used to split the colors of white light into a spectrum. This is called dispersion.
The phenomenon is dispersion, and the thing that you get out of the prism is the spectrum of light. Now, ये जो concept है, ये बहुत important concept है. Now, what I'm teaching, that's called total internal reflection. What is the word here? What word is this?
Total internal reflection.
What is it? The word says
total.
ये क्या कह रहा है? What is the word here?
Reflection.
It's reflection. But ये पता है हम कौन से टॉपिक के अंदर पढ़ रहे हैं?
Physics.
Refraction में. Physics सब्जेक्ट है. Refraction में. So we are talking about reflection within refraction. Are you getting my point? So there is something going to happen now जहाँ पर आप reflection पढ़ने वाले हो, but you're in the topic of refraction. समझ गए? Why is it important? Okay. Now this total internal reflection occurs
because of refraction, right? Angle of refraction.
हाँ, so ये कुछ ऐसा होगा. I'll tell you what exactly is this. ध्यान से देखना यहाँ पे क्या होता है. Light is incident on a boundary between optically more or less dense substance, for example, glass and air. This is glass, this is air. Light is यहाँ से आ रही है light, तो ये denser medium है और rarer medium है, so it will move away from the normal. That is what is happening, right? अभी क्या हो रहा है? The angle of incidence is greater than the, so there is a particular angle which you will see later, which is called as the critical angle. हम critical angles के साथ अभी compare कर रहे हैं. As of now, angle of incidence जो है वो एक certain angle होगा, हर एक medium का एक critical angle होगा, जो हम बाद में देखते हैं क्या होता है वो. I'll show you another picture also. Hold on. Wait.
Okay, what is critical angle?
I'll tell you. Can you see this diagram? ये आप diagram देख पा रहे हो यहाँ पे? Both of you can see, right? Okay.
Yes.
Now look at this. There's a lamp which is inside water. पानी के नीचे लगा हुआ, पानी के अंदर है, ठीक है? तो obviously उससे light निकलेगी, वो light incident होगी हमारे लिए, ये angle of incidence होगा और वो refract होके बाहर आ जाएगी और उसमें से एक बहुत छोटा सा portion जो है वो reflect भी हो जाता है अंदर ही अंदर, ठीक है? अब हमने क्या किया, इस लैंप को शिफ्ट करना स्टार्ट किया. Now this lamp is here. So do you see that angle has increased? Angle has increased, right? तो जैसे ये जितना मैं इधर करूंगी ये एंगल इंक्रीज होगा और इस एंगल में क्या आएगा, दिस एंगल विल आल्सो कीप ऑन मूविंग, बड़ा होता जाएगा, राइट? एक पॉइंट आएगा कि आपने इस एंगल को इतना इस तरफ शिफ्ट कर दिया दैट ये एंगल एक पहुंच गया क्रिटिकल एंगल, जहां पर ये जो रिफ्रैक्टेड रे है वो इंस्टेड ऑफ गोइंग लाइक दिस इट इज गोइंग ऑन द सरफेस. That angle at which it is getting refracted at the surface is called the critical angle. Let me repeat this whole thing once more. ध्यान से समझते हैं हम लोग इसको. हमने क्या किया है कि हमारे पास ये वाला सिचुएशन है, ये वाला this, that there is a lamp. From the lamp there will be an incident ray. That incident ray will make an angle of incidence and will get refracted at a certain angle. Am I right in saying that? ये एंगल पे रिफ्रैक्ट होगा. आपने क्या किया, अपने एक्सपेरिमेंट के लिए इस लैंप को शिफ्ट करना स्टार्ट किया. जब ये लैंप शिफ्ट हुआ तो ये एंगल ऑफ इंसिडेंस थोड़ा बढ़ जाएगा, ये एंगल ऑफ इंसिडेंस बढ़ेगा, उसके हिसाब से ये एंगल ऑफ रिफ्रैक्शन भी थोड़ा सा बढ़ जाएगा, राइट? फिर आपने और एंगल और शिफ्ट किया लैंप को, ये एंगल और बढ़ गया, ये एंगल और बढ़ गया, फिर आपने और शिफ्ट किया और करते करते आप एक ऐसे एंगल पे ले आए जिस एंगल को जिसको हम क्रिटिकल एंगल बोलते हैं. उसको हम क्रिटिकल एंगल इसलिए बोलते हैं कि जैसे ही आपने इसको इस क्रिटिकल एंगल पे लेके आया, ये जो रिफ्रैक्टेड रे है ये पानी के सरफेस पे यानी कि नॉर्मल से 180 डिग्री एंगल पे रिफ्रैक्ट हुआ. डिड यू गेट द पॉइंट? सो दिस रिफ्रैक्टेड रे स्टार्टेड शिफ्टिंग फ्रॉम हियर टू हियर टू हियर टू हियर टू हियर एंड इट बिकेम लाइक दिस. वो जब ऐसा रिफ्रैक्ट होने लगता है तो जो ये एंगल होता है उस एंगल को हम क्रिटिकल एंगल बोलते हैं. डू यू अंडरस्टैंड दिस?
Yes.
So now आप सोचो कि मैंने अब क्रिटिकल नेक्स्ट स्टेज में मैं क्रिटिकल एंगल से भी ज्यादा एंगल कर दूं ये, तो व्हाट विल स्टार्ट हैपनिंग, ये जो रे है वो अंदर की तरफ आ जाएगा. Now I've made my lamp here, which is now the angle of incidence is more than the critical angle. What will happen? Instead of getting refracted on the surface, ये अंदर घुस जाएगा पानी के वापस, और इसी को हम बोलने लग जाते हैं टोटल इंटरनल रिफ्लेक्शन. कि पानी ये रिफ्रैक्शन का प्रोसेस है बट इसमें बिकॉज हमने क्रिटिकल एंगल से ज्यादा कर दिया एंगल ऑफ इंसिडेंस, तो क्या हुआ, अंदर ही अंदर रिफ्लेक्शन होना स्टार्ट हो गया. सो विद इन रिफ्रैक्शन देयर इज नो रिफ्रैक्शन हैपनिंग एंड इट हैज बिकम अ टोटल इंटरनल रिफ्लेक्शन. डिड यू गेट दिस कॉन्सेप्ट? या सो ये कब होगा, ये हमेशा नहीं होता है, ये तभी होगा जब हमारा एंगल ऑफ इंसिडेंस इज मोर देन द क्रिटिकल एंगल.
Critical angle is different for all substances, right?
Critical angle will be different from, जैसे अगर ये water है तो critical angle of water will be different. अगर ये glass है तो it will be different. Depending on the material it is, it will be different. Clear? ठीक है, बहुत ही ज़्यादा important concept है ये. So have you understood this? This part is understood well?
Yes.
Yeah.
So अब हम जरा ये पार्ट को quickly we'll have a look. What is the formula? So the critical angle equation, you know what is critical angle now? That the incident angle is more than the critical angle. When the incident angle is more than the critical angle, then there is a total internal reflection. In this case, this is the incident angle, which is more than the critical angle. I is greater than the C. In that case, no refraction will happen. Everything will be reflected back inside. So angle of refraction, andar hi andar. There will be a reflection. There will be no refraction here. Now, the critical angle is the angle of incidence in the denser medium that results in an angle of refraction so at critical angle of refraction कितना होता है 90 degree होता है, right? लेकिन अगर हमने critical angle से बड़ा किया अपना angle तो क्या होगा? The total internal reflection will start taking place. So there is a relationship between refractive index and critical angle. Get it? There's a relationship between refractive index and critical angle. And what is that? N is the refractive index of denser medium and C is the critical angle. And the relationship is refractive index is 1 upon sin C. तो अब हमारे पास दो फॉर्मूलाज हो गए. एक फॉर्मूला रिफ्रैक्टिव इंडेक्स निकालने का क्या है? एक फॉर्मूला में क्या सीखा था रिफ्रैक्टिव इंडेक्स निकालने का?
Sin I upon sin R.
N is equal to sin I upon sin R. Okay, this is a case when there is a refraction taking place, right? Now N is equal to 1 upon sin C. ये कब लगेगा हमारा फॉर्मूला?
Which one?
ये कब लगेगा?
Critical angle.
When the angle of incidence is at a critical angle. ठीक है? Right? मैंने आपको हमें critical angle दिया हुआ. हाँ. Done? ठीक है. So let's discuss all of this now in the next class. We'll continue this in the next class also.
Yeah.